April 2025. At dawn, 5 of the Philippines' most dangerous volcanoes burst to life. Canlaon's instruments spike at 5:51 a.m., an ash column follows, alarms multiply, and suddenly the nation is facing a scenario even experts thought impossible. Filipino supervolcanoes awakening almost simultaneously. How did a routine shift turn into a race to stop disaster, and what could possibly come next? At 5:51 a.m., the first alarm slams through the PHIVOLCS command center. Canlaon's seismic feed, usually a flat line of background noise, erupts into jagged spikes, over 60 volcanic earthquakes before sunrise. The director, half a cup of coffee in, stands rigid as the numbers climb. Every terminal in the room flickers red with warning codes. By 6:47, the mountain answers. A column of ash punches skyward, rising past 4,000 meters, blotting out the early light over Negros. The official order is immediate. Alert level 3. 5 barangays fall within the evacuation zone. The director fires off instructions to field teams and local officials. Phones ring in quick bursts. Within 20 minutes, the message is out. Move now. There's no time for debate. Data streams in from seismic arrays, gas sensors, satellite feeds, each confirming the eruption is real, not a sensor glitch. The dashboard, built for routine, now scrolls with cascading alerts. Situation reports are drafted on the fly. The director scans the evacuation map, recalculates risk zones, and signs off on the first bulletin. Every minute counts. Staff coordinate with the National Disaster Risk Reduction and Management Council, pushing updates to mayors and emergency coordinators. The pace is relentless. Flights are rerouted from Iloilo as ash drifts east. In the background, the hum of servers and the staccato of incoming data create a rhythm of crisis. For the first time in years, every decision at PHIVOLCS is made in real time, with the clock ticking and the stakes measured in thousands of lives. 12-hour shifts become the new normal inside PHIVOLCS. Engineers shuffle between terminals, eyes locked on graphs that refuse to calm down. The hum of the servers turns ragged. Data packets lag by precious seconds as live feeds pour in from 4 islands at once. Every workstation blinks with a different crisis. Canlaon's ashfall, Tayal's tremors, Bulusan's gas spikes, even the coffee runs out before sunrise. Field teams call in from evacuation zones, their voices rough after sleepless nights. Some haven't left the office in days, catching naps on plastic chairs, eating instant noodles between alert updates. The pressure isn't just technical. Messages from city halls and resort owners stack up, pleading for reassurance. Summer season is about to begin, and every raised alert threatens thousands of bookings. A memo from a regional tourism board circulates quietly, warning that unnecessary panic could devastate local economies. On the operations floor, staff weigh every word in public bulletins, knowing that a single phrase could trigger either mass evacuation or angry calls from business groups. Meanwhile, equipment failures creep in. A sulfur dioxide station at Tal goes offline for hours, just as gas levels are rumored to be rising. Procurement delays mean a replacement won't arrive for weeks. Staff improvise, rerouting sensors and relying on patchy satellite data. Every new glitch means another blind spot. As the dashboard fills with alerts, the room grows tense. The strain shows in short tempers and silent stares. Each decision, who to evacuate, which warning to send, carries the weight of lives and livelihoods. There is no margin for error and no time to rest. Dr. Elias Navarro stands over a scatter of seismic charts, tracing the abrupt spike in volcanic quakes that followed the Mindanao earthquake. On April 10th, a magnitude 7.4 rupture ripped through the crust near Davao, sending aftershocks across the region. Within 48 hours, volcano tectonic swarms ignited Canlaon, 60 quakes before dawn, then ripple outward. Bulusan logs nearly 300 tremors in just 4 days, and Tayal's gas flux jumps above 1,000 tons of sulfur dioxide per day. The timing is too tight to ignore. Navarro, a geophysicist known for chasing patterns others dismiss, overlays the quake's timeline onto the unrest. His hypothesis: the tectonic jolt unlocked ancient magma bottlenecks, sending pressure waves through the archipelago's crust. He pores over magnetotelluric surveys and finds hints of a conductive corridor, a possible thread of partial melt, stretching from Canleon toward Bulusan, with echoes near Tal. If even a fragile connection exists, a major eruption at one could set off a chain reaction, overwhelming evacuation plans built for isolated events. He shares his findings in a midnight call with PHIVOLCS analysts. Some are skeptical, wary of reading order into chaos, but the stakes are clear. Navarro pushes for a joint deep imaging campaign with the USGS, aiming to map the suspected corridors in unprecedented detail. The urgency is real. If the corridor exists, the Philippines faces a risk scenario no one has planned for, a domino effect where one eruption could prime others, turning a local disaster into a national crisis. Dr. Liza Marcado stands before the FIVOLCS board, laser pointer in hand, as tomography slices flicker across the conference screen. Each volcano, Canleon, Bulusan, Taal, shows its own distinct reservoir, isolated by thick bands of unbroken crust. The images are sharp, no corridors, no filaments, just solitary pockets of partially melted rock rising from the mantle. She moves to isotope charts, strontium, neodymium, lead, each tracing a unique chemical signature. Taal's samples, rich in sediment-derived elements, refuse to match Canleon's oceanic crust fingerprint or Bulusan's volatile-laden profile. Even the gas ratios split the story. Taal's high carbon dioxide to sulfur dioxide points to a hydrothermal system, while Bulusan's sulfur surge and Canleon's mixed emissions tell different tales. Marcado's voice is even, but the data leaves little room for doubt. Every line of evidence, geochemistry, tomography, ground deformation, converges on the same answer. These volcanoes are not linked by any continuous magma path. GPS and INSAR records confirm that when one inflates, the others remain still. No regional bulge, no synchronized uplift. The patterns Navarro flagged are compelling, but the evidence is stubborn. The board faces a razor-edged decision. The corridor theory is dismantled, but the risk on the ground remains unchanged. Advisory drafts pile up on the table. Should evacuation zones be widened in case of a rare chain reaction, or should resources stay concentrated where the data demands? The clock ticks. The board weighs Marcado's findings against the chaos outside. Ashfall, evacuations, and a nation waiting for answers. Every advisory now rests on the knife edge between caution and overreach. Inside crowded gyms and makeshift tent cities, families settle onto thin mats beneath flickering fluorescent lights. The air is thick with the smell of ash and sweat. Parents ration water and instant noodles, trying to keep children occupied as lines form for donated blankets. On Negros alone, more than 57,000 people have been uprooted. Lives reduced to what could be carried in a hurry. School classrooms double as dormitories, their chalkboards now covered with lists of missing relatives and relief schedules. In one corner, a mother soothes her coughing baby while her eldest helps sweep up the fine gray dust that seeps through every seam. The days blur together. Rumors about the volcano's next move ripple through the crowd faster than official updates. For many, the hardest part is not knowing when or if they'll be able to return home. Ash clings to every surface as PHIVOLCS field teams scramble between eruptions, improvising data relays when power lines and roads vanish under debris. Scientists, faces streaked with grit, huddle in battered vehicles, sending seismic readouts by satellite phone when stations fail. The ordeal exposes every weakness: aging sensors, patchy radio coverage, supplies stretched to the limit. In Manila, officials pledge a rapid overhaul. A new budget funds dozens of seismic stations and advanced gas analyzers, with emergency procurement orders bypassing red tape. Lawmakers push a bill to guarantee annual upgrades and faster deployment for at-risk provinces. By June, the first new sensors are installed at Con Leon and Tal, with more on the way. Training workshops expand, and a partnership with USGS brings fresh expertise. For the scientists who weathered the crisis, the reforms promise a future where no eruption catches them blind. By the end of May 2025, more than 57,000 people had been displaced by simultaneous unrest at Con Leon, Bulusan, Tal, Mayon, and Hibok-Hibok. Scientific records confirm that a magnitude 7.4 earthquake in Mindanao preceded a surge in volcanic tremor across multiple sites, raising urgent questions about possible connections. Yet, detailed tomography, isotope analysis, and satellite data reveal these volcanoes have separate magma systems and distinct chemical signatures. Experts agree, there is no evidence of a single underground corridor linking them. Still, the crisis exposed gaps in monitoring and response. FIVOLCS and the Department of Science and Technology documented procurement reforms and plans to expand monitoring networks. What remains unknown is the full extent of how regional tectonic forces might synchronize unrest. For the Philippines, the lesson is clear. Preparedness depends on constant vigilance, robust science, and rapid action. The story of these eruptions is not just about geology, but about resilience in the face of uncertainty.